hydraulic press. This is a device which is based on Pascal's law, and it is used to magnify the force. This may be the definition of hydraulic press. Hydraulic press can be defined as the device based on Pascal's law, and it is used to magnify the force. If we apply 100 Newton force on this hydraulic press, it will magnify it to 1000 Newton. If we apply 200 Newton, it will magnify it to 2000 Newton or more than that. That's why this hydraulic press, which is based on Pascal's law, magnifies the force. Now let's talk about its construction. Look at this. Hydraulic press consists of two vessels. A small vessel connected to a big vessel by means of a narrow tube. In its construction, small vessel is connected to a big vessel by means of a narrow tube, and both the vessel are fitted with a piston. Certainly small vessel is fitted with a small piston, and big vessel, its mouth is fitted with big piston, and it is filled with certain liquid. We can fill it with liquid. Now this is construction of hydraulic press. Now question comes, how it magnifies the force? When a small amount of force is applied on the small piston at this place, if a force is applied, let's say the force is F1. F1 force is applied on the small piston, then this force exerts pressure on the liquid through this much surface area, and this area, let's say this is A1, area of the small piston. Then the pressure exerted on this small vessel then transmits to big vessel through liquid. Now this liquid transmits pressure from small piston to big piston according to Pascal's law, because Pascal's law says that pressure exerted at any point in a confined liquid transmits equally to all the direction. That's why the same pressure now transmits to big piston also. Pressure on this small piston can be represented like this, F1 by A1, because pressure equal to force by area. That's why F1 by A1 on a small piston. But in big piston, the force produced because of this pressure is, let's say, F2. F2 is the force produced on the big piston, and area of the big piston is, let's say, A2. Then pressure on the big piston will be F2 by A2. According to Pascal's law, same pressure transmits to this place also. That's why F1 by A1 equal to F2 by A2. This is an equation obtained by hydraulic press. Now the question comes, how it magnifies the force? We can take certain value. Just for example, let's say force applied on the small piston is just 1 Newton. And area of this small piston, let's say 2 meters square. Then the pressure which transmit to this place exerts force on the big piston. We are going to calculate force on big piston. Let's say F2 equal to question mark. Area of this big piston can be considered like this. Let's say it is 50 meters square. Why I am saying 50 meters square? Because the small one is 2 meters square, then certainly bigger one must have greater value of area. If we put this all value in place of F1, it is 1 Newton. In place of A1, it is 2 meters square. And in place of F2, we are going to calculate. That's why F2 remains same. A2 is a 50 meters square. Then meter square cancel. 2 ones are 2, 2 twos are 4, and 10, 2 fives are 10. It means F2 is equal to 25 into 1. 25 into 1, 25 Newton equal to F2. Therefore, we can say that F2 equal to 25 Newton. Look at this value. 1 Newton force is applied on a small piston, but the same appeared as 25 Newton on the big piston. What it mean? This hydraulic press is magnifying the force. The reason is very simple. when we apply certain force on piston, small piston, it exerts pressure. Same pressure transmits to big piston according to Pascal's law, but area of big piston is comparatively very huge than that of the small piston, so force magnifies at big piston and we can lift up a heavy object placed on the big piston.